we have problem number 8 from the back of the practice quiz, and we're going to see how long this track star stays in the air. All right, we've already talked about this before. What determines how long a projectile is going to stay in the air? The y component of its initial velocity. All right, so we got a weird small angle here, only 20 degrees, so I'll try to draw on something like this. So we'll call that 20 degrees. Theta is equal to 20 degrees. All right, and what's the initial velocity? 12 meters per second. All right, so now to determine how long something's in the air, this is just what kind of problem from the projectile packet? It's a full parabola problem, and we'll solve for t. Okay, so for a full parabola problem, we know delta y is equal to 0. And since we're dealing with that, we'll go delta y is equal to v naught yt minus 1/2 gt squared. That's just the, anyone? Meat grinder equation. All right, so since we know that delta y is equal to 0, we can just see these here. We'll add 1/2 gt to each side, and we'll say gt squared, sorry. 1/2 gt squared is equal to v naught yt. All right, and we'll cancel out a t from each side. And then we'll say that t is equal to 2 v naught y over g. All right, so what is v naught y? V naught sine theta, good, over g. Now, how come it's not negative g? Should we put in negative 9.8 for this? We've already accounted for the fact that g is negative, or the y acceleration is negative g specifically, when we set up the equation to begin with. So now we say that t is equal to 2 times 12 meters per second times the sine of 20 degrees all over 9.8 meters per second squared. All right, so now what is that going to give us dimensionally? Let's take a look quickly. We get meters per second over meters per second squared, and then we end up canceling meters. This cancels out one of these. We get 1 over 1 over seconds, which is seconds. All right, so that gives us time. That's what we're looking for. So now, when we plug all the stuff in, the calculator brigade says 0.84 seconds is how long the track star will be in the air.